So today is just an extension of yesterday's assignment. So we're going to be solving exponential equations some more. So let's look at this first one I want to solve. We have 3/5 times 2 to the a power plus 5 is equal to 32. So this is an exponential equation. And again, the reason it's an exponential equation is because our variable a is in my exponent up here. So what we want to do is we want to get that exponent by itself. I want to get, not the exponent by itself, but yeah, I do eventually want to get the exponent. I want to get the a by itself, but I want to get my power by itself first. So what I'm going to have to do is I need to get this by itself. So you can think of this as like a big giant X. So it's like having this equation. 3/5 times X plus 5 is equal to 32. So if you want to get the power by itself, you would have to get the X by itself. So what would we do to solve this equation? Well, we could get it done in 2 steps. We could subtract 5 from both sides, and then multiply both sides by 5/3. That's what we're going to do up here. So our first step would be minus 5 on both sides of this equation. So now we got 3/5 times 2 to the a power is equal to 32 minus 5, which is what, 27, I believe? So 32 minus 5 is 27. We're still trying to get this power by itself. So what we have in front of this power is the fraction 5/3. So to get rid of the fraction 5/3, let's multiply both sides by the reciprocal. To get rid of the fraction 3/5, so we're going to multiply by the 5/3. So here the 5's cancel out, the 3's cancel out. So now you got 2 to the a power is equal to, well, let's turn 27 into a fraction by putting it over 1. 3 can go into 27 9 times. So we got, on the right-hand side, 9 times 5 is 45. So now it's just like the problems we did yesterday. So now we can either do the log or natural log on both sides. I'm just going to do the log. It doesn't matter which one you use on this problem. And then we can take my exponent here, the a, move to the front. So now I got a times the log of 2 is equal to the log of 45. So we would divide both sides by the log of 2 to get the a by itself. So we have a is equal to the log of 45 divided by the log of 2. That's the exact value of a. I want to see this, remember. You got to show your work. And then let's use our calculator to approximate the value of a. Let's type in the log of 45 divided by the log of 2. So a is about 5.4919. All right, let's try one more example. This is basically review. So here's the last example. 5 times e to the negative 2a plus 7 is equal to 32. So again, your goal is to get your power by itself. I want to get e to the negative 2a by itself. So just treat it like it's an x. So treat it as if it was this problem. 5x plus 7 equals 32. You need to know where to start. Replace your power with an x. So to start this equation in red, we would subtract 7 from both sides and then divide by 5. We'll get it done in 2 steps. So to get that power by itself, I can get it by itself in 2 steps. I would subtract 7 from both sides. So then we end up with what? 5 times e to the negative 2a is equal to 32 minus 7 is 25. And then I can divide both sides by 5. This cancels out. And then I get e to the negative 2a is equal to 25 divided by 5 is 5. Now in the last one, we took the log of both sides. And I said you could have took the natural log. It didn't matter. But on this particular one, because e is involved, you want to use the natural log. So anytime e is involved, use the natural log. Don't do the common log. You could do the common log, but it's going to be more difficult. It'll be easier to use the natural log. And again, the reason we're using the natural log is because of this number e. So we will take the natural log of both sides. And then let's take our exponent here, move to the front. So we get this, negative 2a times the natural log of e is equal to the natural log of 5. Now, when we first learned about the natural log, I told you there's something I want you to remember. It's very important. The natural log of e is 1. The natural log of e is 1. So this is really 1 times negative 2a, which just gives us negative 2a. So now we got negative 2a is equal to the natural log of 5. So a would equal, well, to get a by itself, I would divide both sides by negative 2. So a would equal the natural log of 5 divided by negative 2. There's the exact answer, the value of a. And now I just want you to approximate it using your calculator. So let's type in the natural log of 5. Make sure you close your parentheses. It equals, or you can divide it by negative 2. Make sure you're using the negative button, not the minus button. And we get about negative 0.8047. So this is what you're going to be working on today. So again, it doesn't matter which one you use, log, the common logarithm, or the natural log, unless e is involved. If e is involved, let's use the natural log.